When most people think of gemstones, they imagine minerals forged deep within Earth. Diamonds crystallize under immense pressure. Emeralds grow within hydrothermal systems. Peridot forms in Earth's mantle before being carried to the surface by volcanoes. Their stories begin with geology. But not all gemstones follow that path. Some gemstones originate from living organisms. Some are produced by animals that are still alive today. Some preserve ecosystems that vanished millions of years ago. Some are fossils. Together, they reveal an unusual truth. Not all gemstones are records of Earth's geology. Some are records of life itself. In many ways, organic gemstones function as a form of biological memory. They preserve traces of ancient forests, ancient oceans, living creatures, and extinct species long after the original organisms have disappeared. Some are still being created today. Others preserve worlds that vanished before humans existed. Together, they form a journey from living organisms into deep time. Their stories begin not in the mantle, but in the living world. One of the most familiar examples is amber. Amber begins as tree resin. Unlike sap, which transports nutrients through a plant, resin serves as a protective substance. When a tree is injured, resin can seal wounds and help defend against insects and disease. Occasionally, that sticky resin traps more than the threat it was intended to stop. Insects, spiders, pollen, leaves, feathers, and even tiny fragments of entire ecosystems can become embedded within it. If the resin is buried quickly enough, pressure and time gradually transform it. Millions of years later, the result is amber. Rather than preserving a single organism, amber often preserves moments in time. A spider hunting an insect, a feather drifting through an ancient forest, pollen carried by the wind. These snapshots provide scientists with remarkable windows into ecosystems that no longer exist. The idea inspired one of the most famous scenes in popular culture. Jurassic Park used mosquitoes trapped in amber as the foundation for its story. While ancient DNA does not survive long enough to recreate dinosaurs, the preserved insects themselves are very real. Amber remains one of the closest things we have to a biological time capsule. If amber preserves ancient life, pearls represent life actively creating something beautiful in the present. Unlike fossils, pearls form while the organism is alive. When an irritant becomes trapped inside a mollusk, the animal responds by coating it with layer after layer of nacre. Over time, those layers accumulate into a pearl. The process is slow, repetitive, and entirely biological. Every pearl is the result of growth recorded layer by layer. For thousands of years, pearls have been associated with wealth, beauty, and royalty. Yet beneath those cultural meanings lies a simple biological process. A living animal responds to a challenge by building something new. The same nacre that forms pearls also lines the interior of many shells. This shimmering material is known as mother of pearl. Its iridescent colors are not pigments. Instead, they emerge from microscopic layers that interact with light. This phenomenon is known as structural coloration. The colors are not painted onto the material, they emerge from its architecture. The same principle appears throughout the natural world. It can be found in butterfly wings, peacock feathers, and certain shells. One of the most striking examples appears in abalone. Abalone are large marine gastropods, essentially giant sea snails. The interior of their shells displays remarkable blues, greens, purples, pinks, and golds. Like mother of pearl, these colors emerge from microscopic structures rather than dyes or pigments. Abalone shells have been used in jewelry, trade, and ceremonial objects throughout many coastal cultures, including indigenous peoples of the Pacific Northwest, Maori communities in New Zealand, and cultures throughout the Pacific. Some species even produce abalone pearls, among the rarest and most colorful pearls in the world. Together, pearls, mother of pearl, and abalone reveal an important idea. Sometimes beauty emerges not from pigments, but from structure itself. The arrangement of microscopic layers becomes visible as color. A similar lesson appears beneath the ocean's surface. Coral gemstones originate from the skeletons of colonial marine animals. Although coral is often mistaken for a plant, it is actually an animal. Individual coral polyps build calcium carbonate skeletons that accumulate over generations. Over time, entire reef systems emerge from the combined activity of countless tiny organisms. Unlike a pearl, which represents the work of a single animal, coral represents community. It is architecture built collectively. For thousands of years, coral has been used in jewelry and trade throughout Mediterranean, Asian, and coastal cultures around the world. Its deeper story, however, is one of cooperation. Entire structures created not by individuals, but by communities. In that sense, coral records generations of biological activity layered upon one another, creating living archives that can persist for centuries or even millennia. Not all organic gemstones originate from shells or reefs. Some begin as entire forests. Jet is fossilized wood. Ancient forests become buried beneath sediment. Over long periods of time, pressure removes water and transforms the organic material into a dense black substance known as jet. Unlike amber, which preserves resin, jet preserves the wood itself. The result is lightweight, warm to the touch, and easily carved. Throughout history, jet became particularly associated with mourning jewelry, especially during the Victorian era. Yet beneath the cultural symbolism lies another form of preservation. Jet is, in essence, a fossilized forest, a reminder that even trees can leave traces behind. By this point, a pattern begins to emerge. Amber preserves ecosystems, pearls preserve growth. Coral preserves communities, jet preserves forests. Each material records something about life, and each carries that record forward through time. Ammolite preserves something even stranger. It begins with an extinct animal. Ammonites were marine cephalopods related to modern squid, octopus, and nautilus. They thrived for hundreds of millions of years and inhabited oceans around the world. Their shells followed a logarithmic spiral, a pattern also found in hurricanes, galaxies, ferns, and sunflowers. As the animal grew, new chambers were added while the overall shape remained consistent. The geometry of the shell reflected a broader pattern found throughout nature. Around 70 to 75 million years ago, many ammonites lived within a vast inland sea that covered much of what is now Alberta. Known as the Western Interior Seaway, this shallow ocean stretched from the Arctic Ocean to the Gulf of Mexico. Ammonites shared these waters with sharks, giant fish, marine reptiles, and mosasaurs. When the animals died, their shells settled onto the seafloor. Most fossil shells lose their original microscopic structure over time. A small number did not. In rare circumstances, portions of the shell retain the layered architecture responsible for their colors. Millions of years later, those preserved shells became ammolite. The resulting gemstone displays extraordinary flashes of red, orange, yellow, green, blue, and violet. Like mother of pearl and abalone, the colors arise through structural coloration. The difference is that ammolite preserves the same optical phenomenon after fossilization. Today, ammolite remains one of the rarest gemstones on Earth. It is simultaneously a fossil, a shell, an extinct animal, and a gemstone. Very few materials can make all four claims. Taken together, these organic gemstones reveal a progression through time. Pearls are created by living animals. Abalone remains part of a living organism. Amber preserves ancient ecosystems. Jet preserves ancient forests. Ammolite preserves an extinct animal. The journey moves gradually from living biological processes into increasingly ancient forms of preserved life, from living time into deep time. Perhaps that is what makes organic gemstones so fascinating. Most gemstones tell geological stories. Organic gemstones tell biological ones. Some preserve forests, some preserve oceans, some preserve communities, some preserve growth itself, and one of them preserves the shell of an extinct creature that swam through a vanished sea tens of millions of years before humans ever appeared.